Houston Community College is planning to construct a rectangular parking lot on land bordered on one side by a highway. The plan is to use 640 feet of fencing to fence off the other 3 sides. What should the dimensions of the lot be if the enclosed area is to be a maximum? What is the maximum area? Let's first draw a figure to visualize this problem. We have a rectangular parking lot where one side of the rectangle will not be fenced in. And so we'll use a dashed line for that side so that we remember that that side will not have fencing. Now we'll assign our variables. We'll let x equal the width of the rectangle. So we'll label our figure where we have 2 widths of the rectangle that are labeled with x, and we'll make note that we're letting x equal the width. And then the other side is the length of the rectangle that is unknown. We're told that the plan is to use 640 feet of fencing, and thus we know that x plus the length is equal to 640 feet. In other words, 2x plus the length is equal to 640, and thus the length is equal to 640 minus 2x. So now we have an expression for our width and for our length. The area function of this rectangle, a of x, will be equal to the product of the length times the width. So a of x is equal to 640 minus 2x, all times x, which multiplying is equal to negative 2x squared plus 640x. The graph of this function is a parabola that opens down, and thus the vertex will be located at the maximum point on the parabola. So we'll want to find the vertex. The x-coordinate of the vertex is negative b over 2a, and so the x-coordinate of the vertex is negative b over 2a. So in this case, it's negative 640 divided by 2 times negative 2, which is equal to negative 640 divided by negative 4, or 160. So we want to find the function evaluated at that vertex. So we need to find a of 160. A of 160 is equal to negative 2 times 160 squared plus 640 times 160. Simplifying, a of 160 is equal to 51,200. This tells us that the vertex occurs at the point 160, 51,200, and therefore the maximum area will be 51,200 square feet, and this will occur when the width is 160 feet and the length is 640 minus 2 times 160 feet, or 320 feet.